Okay guys, so this is a video in relation to how to perform a t-test. This is a independence between groups design t-test. I'm going to show you how to do a histogram, how to check for normality using the Shapiro-Wilks test, which will inform you in terms of whether you need to do a parametric, which is the between groups t-test, or whether you need to use the Mann-Whitney U-test, which is the non-parametric version. I'm not going to go into the specific details in relation to what those are. That's for a separate video. But what I will do is basically just show you how to run those tests. So here we have some data that runs from participant 1 to participant 24. Now, this is a between groups design. So what we have here are two groups of people, and I'm going to show you, I'm just going to delete these for a second just to show you. These people here represent people who are stressed, and they're in the control condition. And these people here, forget the 2 for a second, they represent the people in the intervention condition. So the guys in the intervention condition are going to receive a brief mindfulness intervention. And the experiment is trying to find out whether brief mindfulness is enough to reduce their stress or anxiety levels. So the way to do this with a between groups design, we've got the group 1 data there, so that's the stress scores. We have the grouping variable there, that means group 1, control group. These are the people who are not going to receive the mindfulness intervention. Now, the second group, we paste them, or we enter the data underneath. So these are the stressed individuals. These are also stressed individuals, but who have received a mindfulness condition. So these guys have not, these guys have. So this is a between groups design. If we go into variable view, just delete these, clear, clear, clear. You've got stress there and group there. That's stress and group. You've got a label that I entered there, score. I reduced the decimals down to 0 and place the label there, condition, just to notify a user of the data that this is a condition group. And then pre-post, I'll just remove these and redo them. We want 1 for the label is control. So those guys did not receive the intervention. 2 is the mindfulness condition. So these guys did receive the intervention. So again, that's the scores for group 1, the guys in the control who received no intervention, and these are the scores for the guys who received the intervention. The very first thing we want to do is we want to check whether the data is normal. So we click on Analyze, we click on Descriptive Statistics, and then we click on Explore. Go to, well, I've already put in stress as the dependent, so you just click on it, click on the button there, and it pulls it across. Factor list is group, so just move that into that case there. Click on plots. What I've selected here is normality plots, and I've selected histogram. So I want to visually see the data in terms of a histogram, and I want to see what the normality plots actually tell us. This will give us the Shapiro-Wilks test. Click on continue, click on OK, and then it runs the analysis. You can see this is actually very smooth. So this is a normal distribution. You can see the smoothness of the distribution. This too is a slight skewedness there, but it is what seems to be a normal distribution. And if I scroll down, you see a bunch of tables. Where is it? So I'm looking for a table. Here it is, test normality, and Shapiro-Wilks test is there. So this is control, that's the statistic there. Here's the significance. Now, if you want this to be a parametric test, if you want to find normality, this significance needs to be above 0.05. It needs to be above 0.05. Same as this one here. It needs to be above 0.05. If it's below that, you need to use the non-parametric version, which is the Mann-Whitney U test. We'll cover that in the next video. But for data that is normally distributed, like this, nice bell curves, we can go ahead now and do the between groups t-test, the parametric test. And again, there's going to be a separate video in terms of the assumptions and why we use these. I can't go into it in this kind of short 10-minute session in terms of running it. This is about running the actual tests. So I just wanted to show you that. That's the normality plot there, and that's the key Shapiro-Wilks test. Going to get rid of that now. Don't want to save it. Now I want to perform the actual test. So we click on Analyze. We need to compare means. Now the type of test was a between groups design. Another word for this is independent samples test. So click on independent samples. We've got a grouping variable there that goes into grouping variable, and we've got a stress score there that goes into your test variable. Now you'll see two question marks. Click on the box. This has to go yellow. Then you see define groups. Now you can click on define groups. If you don't click on the box, you can't click on define groups. You need to click on this box here, let it go yellow, define the groups, and you just want to call them 1 and 2 because that's what you've actually called them in your SPSS. We've got two groups, 1 and 2. Click OK, and there you have it. First of all, it gives you a descriptives box. So your mean scores was 44.5 for the control group. Your mindfulness condition was 47.25. So it shows greater stress for actually the mindfulness condition. You've got a standard deviation. This is your spread volatility of data. You want this number as low as possible. N is your number. Now, obviously, in this situation, a mindfulness came out with a higher stress score. I just want to let you guys know this is made up data. I've just taken the data up from this Excel sheet here, which is nothing to do with mindfulness. It's actually to do with a completely different variable. But there's your two mean scores in this case. And then if we've got a hypothesis that says something like the mindfulness condition will lead to greater reduction in stress that as compared to the control groups. That's a hypothesis. This would show us, you look at this first and you say, okay, 47 versus 44. These are post-intervention score. You can see it hasn't done that. So you know right off the bat it's actually increased the stress levels in this particular experiment. You look down at your inferential statistic. So this is a descriptive statistic. This is your inferential statistic. And here's the key components that you need. T, and then you've got your T figure here. Then you've got DF, which is degrees of freedom, and I'll explain that in a different video. It's an important number. And then you've got your significance number. This is two-tailed, and I'll explain that in another video. But we know this is well above 0.05. So even if this was lower than the control, you would still have to reject the hypothesis in favor of the null hypothesis, simply because this is non-significant. This would need to be below 0.05 for this to be significant. As it's above 0.05, you can't reject the null hypothesis. The null hypothesis is there will be no difference. So statistically, this is saying there is no difference between the control and the mindfulness conditions in terms of stress levels. So that's absolutely crucial to understand that. Again, I'm going to go into things like confidence intervals in a separate video. I just want to keep this as a very short 10-minute-ish video. But that's what I just wanted to show you, is you take that information there. Crucially, the significance here. I'll show you again how to put that into proper APA format. You put T, and then you have bracket df, close bracket. In the brackets you'd have 22 equals this number here, minus 0.77, and then you have comma, P is equals 0.446. Again, you can't reject a null hypothesis. In any case, even if this was significant, our hypothesis is stipulating that the mindfulness condition would reduce stress more than the control condition, and that's not what we found. So you have to, this is just telling you there's a significant difference between the two groups. The descriptive statistics tells you where that difference lies, which is smaller than the other. Obviously, a limitation of this experiment is you'd have a pre versus post condition. For the purpose of this experiment, I didn't want to do that simply because you'd have to have a 2x2 ANOVA, and this is for a t-test. Anyway, that's how to run a t-test. I hope you enjoyed that. I hope it was informative. Okay, and I will catch you in the next one. Thank you very much.